Welcome! Today we're going to solve an interesting equation that combines two different types of functions. Our goal is to find the value of x that satisfies the equation 2 to the power of x plus x equals 5. The challenge here is that we can't solve this equation algebraically. We have an exponential term and a linear term in the same expression. This means that no amount of rearranging the equation using standard mathematical operations will isolate x. To solve this, we'll need to use a visual approach. By the end of this video, you will be able to estimate the solution to a transcendental equation using graphs. In other words, we'll learn to find the approximate answer by looking at a picture. So, how can we use graphs to help us find a solution? The key is to think of our equation as two separate functions that are equal to each other. We can represent the left side, 2 to the x plus x, as one function, and the right side, 5, as another. Let's call the left side f of x equals 2 to the x plus x, and the right side g of x equals 5. Our equation, f of x equals g of x, means we are looking for the x value where these two functions have the same y value. In other words, we're looking for the x-coordinate of the point where their graphs intersect. By graphing both of these functions on the same set of axes, the point of intersection will reveal the solution to our original equation. This is the visual estimation method. Let's begin by graphing the first function, f of x equals 2 to the x plus x. To do this, we can calculate a few points by plugging in some x values. Let's create a table of values for f of x. For x equals 0, f of 0 equals 2 to the 0, plus 0, which is 1 plus 0, giving us 1. So we have the point 0, 1. Next, for x equals 1, f of 1 is 2 to the first, plus 1, which equals 2 plus 1, or 3. So we have the point 1, 3. And for x equals 2, f of 2 is 2 squared, plus 2, which is 4 plus 2, or 6. That gives us the point 2, 6. Now, let's plot these 3 points on our graph. Connecting these points reveals the shape of our function, f of x. It's an increasing curve that grows more steeply as x increases. This is a combination of an exponential and a linear function. Now let's graph our second function, g of x equals 5. This one is much simpler. It's a horizontal line where the y value is always 5, no matter what x is. We can see this from its definition. G of x equals a constant, 5. So, we just need to draw a horizontal line that passes through the y-axis at the value of 5. Remember, this line represents all points where the y-coordinate is 5. We now have both graphs on the same set of axes. To find our solution, we simply need to find the x-coordinate of the point where they cross. Let's find that intersection point. Look closely at the graph. Do you see where the curve of f of x intersects the straight line of g of x? The intersection occurs right here. It's the only point where the two functions meet. Now, let's look at the x value corresponding to that intersection. It looks like the intersection happens when x is somewhere between 1 and 2. If we were being very precise, we would use a calculator to find the exact value, which is approximately 1.7632. So we'll write down our estimated answer. This value of x is the solution to our equation 2 to the x plus x equals 5. It's the number that makes the equation true. It's always a good idea to check your answer by plugging it back into the original equation. Since we used an approximation, we shouldn't expect the left side to be exactly 5, but it should be very close. Let's check our approximate solution. X is about 1.7632. We'll substitute this value in. 2 to the power of 1.7632 plus 1.7632. If you calculate this, you get approximately 3.2368 plus 1.7632, which equals 5.000. The left side equals 5.000, which is extremely close to the right side 5. This confirms that our graphically estimated solution was correct. So, we have successfully found the approximate solution using the graphical method. Let's quickly recap what we've learned. We started with an equation that was impossible to solve algebraically, an equation of the form f of x equals g of x. Our objective was to estimate the solution to a transcendental equation using graphs. We achieved this by graphing both sides of the equation as separate functions. The x-coordinate of the point where the graphs intersected gave us the approximate solution to the original equation. This graphical method is a powerful tool for solving equations when algebraic methods fail. It allows us to visualize the solution and find a very good approximation. Thank you for watching.